Section 13.4, Law of Sines. When solving a triangle, and if we're given two sides and an angle, and it appears that it's going to be a law of sines problem, which means that I have a pair, so one of the sides is across from the angle, then I must check whether or not a triangle exists, exactly one triangle exists, or in some cases there will actually be two possible triangles that exist. So, suppose I'm given two sides and an angle for a triangle. If my angle is acute, if my angle is acute, there are four different possibilities that could happen. Possibility number one, before that, in all of the possibilities, I'm going to find my height to be b times my sine of my angle. So it's the side not across from the angle times the sine of the angle. So no solution exists. There is not a triangle if A is acute and the side across from my angle is less than the height, which A is your side across from the angle. That means no triangle exists. If A is acute, then I could have one triangle that exists. And one triangle exists if I have that the side across from the given angle equals my height. If that's the case, then I have exactly one solution. I also have one solution if the side across from the given angle is greater than and equal to the other side. In both of these cases, I have exactly one solution. Now my fourth option, if A is acute, then I could have two solutions. One is I have the height must be less than the side across from the given angle, which also must be less than the other side. If this happens, then I have two triangles that must exist. And later we will show how to solve for both of these triangles. Now, if my given angle is either right or obtuse, then I only have two possibilities. One, if I have the side across from the given angle is less than or equal to the other side. Then I have no solution. That triangle does not exist. A triangle would exist if the side across the given angle must be bigger than the other side. Now, this occurs because the side across from the given angle, it has to be the biggest side in my triangle. So let's take a look at a few examples. Example 1 or 3. In triangle ABC, A is 118 degrees, side A is 20, and side B is 17. So first I would classify that this is obtuse. So because it's obtuse, I need the side across from the angle to be bigger than the side not across from the angle. So since A is bigger than B, that means that I have one triangle. So then I can go through my law of sines. Sine of 118 over 20 equals the sine of B over 17. So that would give me that angle B, after plugging it into my calculator, gives me 49 degrees. And then I would do the sine of 118 over 20 would equal the sine of 13 over C. Because to get angle C, all I did was 180 minus 118 minus 49. So that's why angle C is 13 degrees. And that means side C is 5.1. Next example. In triangle ABC, angle A is 50 degrees, so that means it's acute. So whenever it's acute, I want to find my height, which is going to be equal to 9 times the sine of 50, which is going to be 6.89. Now, because my height is bigger than my A, that means that no triangle exists. And I stop. The next example, angle A is 39 degrees. So that means it's acute. Since it's acute, I want to find my height, which is going to be 14 times the sine of 39, which turns out to be 8.8. So therefore, my height is less than my A, which is less than my B, which means my height is less than the side across from the angle, which is less than the other side. So that means that I have two triangles. All right. So my first triangle, I'm just going to list out all of my angles. So angle A is 39 degrees. Side A is 10. Side B is 14. So first I just go through regularly and I solve that the sine of 39 over 10 is equal to the sine of B over 14. So when I do that, I get B is 61.8 degrees. So that means C equals 79.2 degrees. And then I do the sine of 39 equals the sine of 79.2 over C and over 10. So when I work that out, I get that C is 15.6. All right. Now, to find the second triangle, all of the original information stays exactly the same. So angle A is still 39 degrees. Side A is still 10. Side B is still 14. And side C still unknown. But this time, I take the found angle B from the first one and subtract it from 180. So to find this angle B, I take 180 minus my 61.8. So this angle B is going to be 118.2 degrees. So that means angle C is going to be 22.8 degrees. So then I would just set up that I have the sine of 39 over 10 is going to equal the sine of 22.8 over C. So I get that my C is 6.2. So there are my two triangles and how to find both of them.